Section 10.4, adding, subtracting, and dividing radical expressions. First definition, radicals with the same index. Remember, the index is the guy that sits on the hand of the umbrella, right? So radicals with the same index and the same radicand again is the guy that sits under the umbrella, are called like radicals. So if you have two radical expressions with the same index and with the same radicand, then they are called like radicals. Okay, for example, this guy, the minus 4th root of 2 and 3 times 4th root of 2 are like radicals. It's like an image, right? Think about this thing as an image. This image and this image are the same, right? Okay. All right, add or subtract. This is on page 728. And let's do number 10. 6 square root of 7 minus 3rd root of x plus 2 square root of 7 plus 5 3rd root of x. Well, this image is the same as this image, right? You have 6 of this image plus 2 of that, the same image. 6 of this image plus 2 of them is 8 of them, right? So this is 8 of the image square root of 7. For this image, 3rd root of x, that's the same one, 3rd root of x. So these guys are like radicals. So 5 of this image minus 1 of them is 4 of them, right? So 4 of the image 3rd root of x. Number 12. It looks like these two are not like radicals and hence I cannot add. Well, it's true I cannot add yet, but I can simplify before I realize that there may be like radicals. Okay, so let's simplify. Square root of 5 cannot be simplified because 5 doesn't have a divisor which is a perfect second power other than 1. 20 does, and actually we can rewrite this as 20 is 4 times 5, right? Okay. So this is back to the previous section. We can simplify this. I'm not going to write the details anymore because we wrote the details in the previous section, and supposedly we mastered the concept in some sense. This is simply then 2 square root of 5, right? So what was the technique at the time? You split the product, square root of 2 squared times square root of 5, and square root of 2 squared is simply 2. So this is square root of 5 plus 2 square root of 5. All right, and what's the image then? The image is square root of 5. So now they are like radicals, and hence I can add them up. So 1 copy of this image plus 2 of that same image, I'm gonna have 3 of them. Correct? All right, 16. 5 times square root of 45x minus 2 times square root of 20x. Let's simplify each one and realize that they are like radicals. So 5 times square root of 45. 45 is, let me write this. So 45 is 9 times 5, right? Correct? So this becomes I'm talking about just this guy. This becomes 3 square root of 5x. Correct? Because this is 9. Square root of 9 is 3. times square root of 5x. So this is 3 times square root of 5x. Okay. And how about this guy? Well, we dealt with the 20 right before, and we got 2 square root of 5. So that's going to be 2 square root of 5x then. Correct? Okay. So the first one is 5 times 3 square root of 5x. And the second one is minus the 2 times this thing, which is 2 square root of 5x. Okay. 5 times 3 is 15. Square root of 5x. Minus 2 times 2 is 4 square root of 5x. Okay. So clearly I can combine because this guy and this guy are like radicals. They are the same image. 15 of this image minus 4 of the same image is the same thing as saying 11 of the image. Correct? Because 15 minus 4 is 11. 20. All right. How about we simplify this expression? I want to add them up. I don't have like terms yet. They're not apparent yet. Let's simplify each expression. Let's simplify this first. Square root of 45 times square root of x cubed. I can think about this as square root of 45 times square root of x cubed, right? And square root of 45, we've dealt with it before above. Correct? We found 3 square root of 5 at the time. 3 square root of 5. Remember, I'm simplifying them quicker than before because we took our time in the previous section, okay? So if you still need to work, please revisit the video of the other section, 10.3, and do more exercises. And if you still have questions, please either email me or just post things on Canvas. Okay, just create a discussion and post your question on Canvas, and I'll be happy to reply to it. And it would be actually beneficial to your classmates as well if you have a question, post it on Canvas because they may have the same question, so we cannot answer it for multiple students at the same time. Okay. And it gives the opportunity for other classmates to help you tackle a particular question or understand a certain concept better. All right, so square root of 45 is 3 square root of 5. We talked about this above. Square root of x cubed, this is square root of x squared times square root of x, right? And square root of x squared is absolute value of x, correct? Times square root of x. One more time, why this is the case? Again, this is the previous section. X cubed is x squared times x. Square root of x squared is absolute value of x, and square root of x is right there. And now on this problem, this is number 20, they said here in this section they said all the variables, if you read carefully before the exercises start in this section, they said all the variables represent positive real numbers. So they're being extremely nice. But please understand, so please, when doing the homework, pass through the stage, okay? Don't just skip the absolute value concept, because in the future classes, you may not be given variables that are positive, okay? And if x is negative, for example, and you just drop the bars, this becomes a wrong statement. Okay. All right, so please be careful about this. So here I'm gonna rewrite this as 3 square root of 5 times x times square root of x. And here I want to be very clear that this last equality holds since x is given to be positive number. Correct? All right. This is simplified already. Correct? Actually, I can condense this more. The purple one. That's 3x square root of 5x. And square root of 5x is simplified. So back to this. I can rewrite this as 8 times 3x square root of 5x. I'm talking about number 20. Okay. Plus the square root of 5x, which is equal to 8 times 3 is 24. X square root of 5x plus square root of 5x. All right. And here what I can do is, the best I can do is to factor out that square root of 5x. So this is the best I can do, factor out square root of 5x. And I get 24x plus 1. Okay, so this is number 20. 23. So 54 is 27 times 2. So this becomes the cube root of 27, and 27 is 3 cubed, right? 3 cubed times 2 times x to power 4, and x to power 4 is x to power 3 times x. Let me erase this and fix it. Right? So that becomes, if you let the cube root and the multiplication commute, you get the cube root of 3 cubed. And what's the cube root of 3 cubed? It's 3 times the cube root of 2 times the cube root of x cubed, and the cube root of x cubed is x. Remember, the nth root of an is the absolute value of a if n is even, and it's a if n is odd. In this case, it's odd because the index is 3. All right, and lastly, cube root of x is cube root of x times the cube root of 2 becomes cube root of 2x. Okay, this one, the cube root of 16x, 16 is 2 to power 4, so that becomes the third root of 2 to power 4, which means 2 cubed times 2 times the x, right? 16 is 2 to power 4, and 2 to power 4 is 2 cubed times the 2. And this is simply 2 square root of 2x. Sorry, not square root, cube root of 2x. Because the cube root of 2 cubed is 2, and the cube root of 2x is itself. So all in all, you get, for the first one, it was 3x cube root of 2x minus 2 cube root of 2x. And this is the same thing as if you factor out the cube root of 2x, you get 3x minus 2, right? Okay, 26. Square root of 4x minus 12. Remember, square root doesn't commute with addition or subtraction. So you cannot say this is square root of 4x minus or plus square root of 12. You cannot split them up. Square root splits with multiplication so far, right? And it's gonna split with, it's gonna commute, I should say, with division. It's gonna come in the sequence in this section. Okay. So what I'm gonna do is I'm gonna factor out a 4 here. I'm gonna factor out a 4 in the first expression. I'm getting 4 times x minus 3, right? For the first one, plus the second one. So what I've done is I just factored out 4 because 4x and the 12 are divisible by 4. So factor out the 4, you get this. And then this is a multiplication here, correct? So what we get is square root of 4 times square root of x minus 3. So I split them up. I use this as one of the factors and x minus 3 as the other. So the language is multiplication, so you can split them up. Plus square root of x minus 3. And what's square root of 4? Well, this is 2. So this whole thing becomes 2 square root of x minus 3 plus square root of x minus 3. And this is how much? This guy and this guy are the same. They're like terms. So 2 of this image plus 1. This is 1 of that image. It's 3 of the same image, right? 3 of the square root minus x minus 3 image. Okay, 28. Okay, so I have 4 times this thing, the cube root of x4 y squared plus 5x, the third root of x times y squared. Realize that this guy is simplified. None of the exponent is 3 or more, the index or more. Here I can simplify just the x part. The y squared part is already simplified because the square is less, power 2 is less than 3, right? All right, let's simplify this guy. Well, you can split x to power 4 as x to power 3 times x. And get, this is a square here, and get, this is a multiplication. So the third root of x cubed is x, because n is even. And third root of x times y squared. This would be the value of this, right? This value and this value are the same expression. Plus 5x times this image. Okay, so let's copy it. So this becomes 4 times x cube root of x y cubed. Y squared. I'm talking about the purple thing. So the 4 existed already. 4 times that is the same as 4 times this purple thing. Plus 5x times the cube root of xy squared. Okay, fix the square. All right. And now take a look at this box. This box and this box are the same, aren't they? So think about this box as an image. 4 times this image plus 5 times the same image. How many of the images? 9 of that image, which is x times the cube root of xy squared. Agree? Okay. Property. Remember we had product rule for radicals on the previous section. Now in this section we're gonna have, this is about the quotient rule for radicals, and it goes like this. If the nth root of a and the nth root of b are real numbers with the property that the nth root of b is non-zero, then the nth root of a quotient is the quotient of the nth roots. And I want you also to contrast this as we did in the previous section. I want you to contrast this with with this. Remember in an earlier section, probably a couple sections before, the power of a quotient, at the time we had the power as labeled as P or Q. This is the same as the quotient of the powers, right? And we said the power can be any rational number. In this case, I'm taking 1 over a natural number, and as a natural number here, because it's the index. So this is certainly a rational number. So that becomes, at the time, this is a to power p, which is 1 over n, divided by b to power p, which is 1 over n. Correct? And what this is saying is the same thing. So this property, we knew it already before, but we're highlighting it and we're calling it quotient rule for radicals. Okay, so we're gonna put it in action. Pages 728, 729 on the following numbers. Let's start with 36. The question is to simplify. Simplify this square root of this quotient by the quotient rule for radicals. We know that the square root of a quotient is the quotient of the square root, so I can rewrite this as the quotient of square root of 50 x cubed divided by the square root of 81 y8, correct? Okay. Square root of 50, well, all right, let's write this. Square root of 50 divided by square root of x times square root of x cubed divided by square root of 81 times square root of y to the power 8. Let's simplify each of those 4 radical expressions. Square root of 50. 50 is 25 times 2, right? 50 is 25 times 2. And square root of 25 is 5 times the square root of 2. So this guy is 5 square root of 2 times the second one in the numerator, which is the square root of x cubed. I think we dealt with it just a little earlier. Where is it? It's right there. Square root of x cubed. So square root of x cubed. By the way, I'm kind of bothered with this now because this guy doesn't make sense if x is negative, right? If x is negative, the cube of x is negative, and hence square root doesn't make sense of that entity, correct? So so one more time, if x is negative, this whole thing doesn't make sense, square root of x cubed, because if x is negative, x cubed is negative, and hence the square root of a negative number doesn't make sense. So I'm gonna erase that. I'm gonna erase this guy because it's, I mean, all along, if I want to keep it, I should put it everywhere, right? I should assign it to every equality because each one of them doesn't make sense if x is negative. Okay. All right, so I'm gonna keep this second step as parenthetically in some sense, just to highlight that really don't forget the absolute value of x step, but x is known here all along, as we said that x is positive, so the absolute value of x and x are the same. Okay. All right, so I came back to this to pick up the result. Square root of x cubed, we found it to be x square root of x, right? X square root of x. So I'm going to inherit this and just carry it over. So square root of x cubed is x square root of x. Square root of 81 is 9. times square root of y to power 8 is equal to square root of y to power 4 squared, right? I'm writing it as a perfect second power, perfect square, and then I can now write what it is. What is this box? Well, this is of the form the nth root of a, the a is y to power 4 here, a n, right? So let's follow suit with what we've been doing. I'm gonna erase the y to power 4 and write it in red to highlight that this is actually the base for that. So this is now clearly of the form second root of something to the second power, and this index and this power, they undo each other in a quasi, remember, in a quasi clean fashion we called it. So the answer is the absolute value of a, right? I'm highlighting. So what we're using is the nth root of an in the previous section. The nth root of an is the absolute value of a when n is even, and the n is even because it's 2. So this is absolute value of y to power 4, correct? But y to power 4 is non-negative regardless what y is, so hence the absolute value have no role in this business anymore, right? Because y to power 4 is a non-negative entity. In this case, y cannot be 0 because I'm dividing by y. So this guy, y to power 4, is positive. Why? Because no matter what y is, as long as it's not 0, raise it to power 4, it becomes positive. Taking the absolute value of a positive number is the same as retaining that entity. The absolute value function doesn't do anything on positive entities, right? Okay, so next, this becomes, upstairs it becomes 5x square root of 2x, I'm using the product rule for radicals, divided by 9y4, right? And this is the best I can do. I simplified as much as I could. Number 40. The cube root of 81x8 divided by 8y to power 15. Let's use the quotient rule for radicals. I get the third root of 81x to power 8 upstairs divided by the cube root of 8y to power 15 downstairs. Okay. And 81 is, all right, let's use the let's use the product rule for radicals. I get the third root of 81 times the third root of x8 divided by the third root of 8 times the third root of y15. Okay. Let's find each one of them. Let's start with this. 81 is let's do it this way. 81 is 3 to power 4, right? 3 to power 4. Because it's 3 squared. 3 squared is 9. Square the 9, you get 81. So this 81 is 3 to power 4. So this whole thing, this guy becomes the third root of 3 squared, of 3 to power 4. So 4 is the same thing as 3 plus 1. So this becomes the cube root of 3 cubed times the third root of 3. And the third root of 3 cubed is simply 3 times the third root of the remaining 3. One more time. Where did this come from, the 3? Well, 3 to power 4 is 3 to power 3 times 3. So cube root of 3 to power 3 is 3 times the cube root of 3, which is this part. Okay. Remember, this is the previous section, so we talked intensively over about these in the previous section. How about this one? X to power 8, the largest multiple of 3 and 8 is 6. So this is going to be the third root of x6 times the third root of x squared. And the third root of x to power 6, the third root of x to power 6 is x squared. So that's going to be x squared times the third root of x squared. Correct? Third root of 8 is 2, because 2 cubed is 8. And lastly, this part, this is the third root of y to power 15. Y to power 15, the largest multiple of 3 and 15 is 15 itself. So that's the same as the third root of y to power 5 cubed. And this is of the form the nth root of the nth power of something, and that thing is y to power 5. So the answer is y to power 5 then for this. Okay. So this is then, at the end of the day, it's the green part, which is 3 cube root of 3. Actually, let's do it quickly. So this part is 3 cube root of 3, and this part is x squared cube root of x squared. So it's 3 times x squared. These guys don't have umbrellas. And cube root of 3 times cube root of x squared. Cube root of 3 times cube root of x squared is cube root of 3x squared. And downstairs is simply this guy 2 times this guy, which is y to power 5. Okay. All right, and can I simplify any further? No, that's it, right? This is simplified, so can't touch it because it doesn't have anything any companion downstairs. And all these guys are co-primes. There's no common divisor other than 1, right? Okay. All right, 44. How about I leave 44 as an exercise for you? Just think about it. Let's do 51. Well, now we're gonna use the quotient rule, this one, from right to left. We're given this side, we're gonna try to go this side to this side in some sense. The question in 51 is still simplify. Okay, so divide and simplify. So what I'm gonna do is I'm gonna think about this as the square root of the quotient by the quotient rule just talked about earlier. Divide by xy, right? Remember, square root commute with division. So taking the quotient of square roots is the same as the square root of the quotient. Okay. Now inside the umbrella, let's simplify. x5 divided by x is x to power 4, and y cubed divided by y is y squared. Okay, so this becomes the square root of x4 times the square root of y squared. What's this guy? Well, this is the absolute value of y. And what is this guy? Well, this is the square root of the square of x squared. Yes? The square root of the square of x squared. So this is of the form the nth root of a n again, which is like exactly as we did here, but instead of this y, now we have x squared. So this is technically equal to the absolute value of the pink x squared. But since, I mean, squaring the x, regardless what x is, squaring the x is, I mean, x here cannot be negative, it cannot be 0 because it's downstairs, right? If x is 0, this doesn't make sense. This quotient doesn't make sense. So certainly, implicitly, I mean, the provision to this question is that x is not 0. All right, if x is not 0, square the x, regardless what the x is. I know it's not 0, but it can be negative. The square of x is positive for sure. And then absolute value of a positive number is the number itself. Okay, so we get x squared times the absolute value of y. And here, as discussed earlier, in this section, we are told that y, all the variables are positive. So y is positive, as such, the absolute value of y is y itself. Okay, I'm passing through the stage just to highlight, especially for those who are going to the calculus direction, that this is technically absolute value of y, right? And then because this is the case, I can drop the bars. Okay. Okay, 60. Same first step. What I'm gonna do is I'm gonna take the third root of the quotient by using the quotient rule for radicals, just introduced above. Simplify the quotient. So let's keep the umbrella waiting. Let's simplify the quotient. 250 divided by, I mean, this is the numerical part upstairs and this is the numerical part downstairs. 250 divided by 2 is 125 times the x to power 5 divided by x to power 3 is x to power 5 minus 3, right? So you have 5 copies of x upstairs, 3 copies of x downstairs. You start simplifying, you're gonna be left with 2 upstairs, and then y cubed by itself. Okay. This is the third root of 125. This is now the product rule for quotient. The product rule for radicals. Get this. And this, right? 125 is 25 is 5 cubed, so 25 times 5, and hence this entity is 5 because it's the third root of something cubed. That thing is the answer, right? Okay, this is simplified. How about this? Same reason, this is also y. Same reason, by this I mean as here, right? Okay, so the answer is then 5 times y times this guy. Okay, all right, 70. We're gonna add, but we're gonna simplify in order to be able to combine like radicals. Okay, so let me copy all of this and just drag it above here. Okay, so this is the same as, I'm gonna simplify each of them. This is simplified. I don't have a divisor of 3 other than 1 that's a perfect square. Similarly for x. Oh, y squared is not simplified, so I can simplify this guy. So I get 6x times the absolute value of y times square root of 3x minus the x and y here. I cannot do, they don't have, none of them has a divisor that's a perfect second power or perfect squared, but 27 does, and 27 is divisible by 9, which is a perfect second power, so you get 4x squared times 3 square root of 3, right? And the xy existed already. How do we get that? 27 is 3 squared times 3, so 3 squared, square root of 3 squared is 3, and what's left inside is 3xy minus 5 times square root of 75. You know what, let me just do this by itself like this. Let me split them up and get this right. Okay, 75, I meant to have a different color. So 75 is 5 squared, which is 25, times 3. Okay, so what can we say about this block? Then this is 5 square root of 3, right? Because square root of 25 is 5 times square root of 3. Square root of x 5, so this block here, the brown one, let's say, well, this is the square root of x to power 4 times x, and this is the square root of x to power 4 times the square root of x, and square root of x to power 4 is absolute value of x squared, right? Times the square root of x. But regardless what x is, x squared is non-negative, so the absolute value of a non-negative number is that number. So this becomes x squared times square root of x. Okay. All right, back to the purple writing. So we get here a 6x absolute value of y times the square root of 3x minus 4x squared. Well, I can multiply here the 4 and the 3, right? I can multiply the 4 and the 3. 4 times 3 is 12. X squared times the square root of 3xy minus the last part. And what's the last part? 5 times 5, which is 25, x squared, and square root of 3 times square root of x times square root of y is square root of 3xy. Okay. Correct. One more time for the last one. 25. Where did this 25 come from? 5 times 5. X squared, this entity. And I have square root of 3 coming from the pink block. I have square root of x from the brown block, and the purple one, which is square root of y. Square root of 3 times square root of x times square root of y. Use the product rule for radicals. You get square root of 3 x, y. Okay. This image, the square root of 3x, I don't see that image right anymore. This is a different image, right? Because they're not like radical. The square root of x, the square root of 3x and square root of 3xy, they're not like radicals. Why? Even though they have the same index, but they should have had the same radicand, so they would be like. But they don't. One has 3x and one has 3xy. So this is by itself. I'm gonna just keep it. Okay. And over here, the image is, let me highlight the image. This is the image. That's the same image over here. Correct? So minus 12x squared, actually I can involve this in the image. Oops. I can think about this whole thing as being the image. That's the same image, you see? X squared square root of 3xy. This is one package, and that package is the same as this package. So I have minus 12 of this package, minus 25 of the same package. I have minus 37 of that package, which is x squared square root of 3xy, right? Agree with me? Okay, let me just erase all of these. Okay. And that's it. Probably one last step. We know, as we mentioned before, we know that the variables given, all of the variables given in this section are positive. So this is what they said. So absolute value of y is y. So let's write that. So 6xy square root of 3x minus 37x squared square root of 3xy. Okay, and this, the reason is that y is positive. It was given to us in this at the beginning of this these practice exercises in the book. Okay. All right. 73. You know what? I'm gonna keep 73 as an exercise. I'm gonna do 76. Okay. Let me copy this. Put it here. So please complete 73 on your own, and let's do 76 together. Okay. Apparently 76 is more complicated than 73, so please complete this 73 on your own. Okay, so how can we handle 76? Take a look. Please pause it and try it on your own, and then run the video. It would be best to do so. I'm going to simplify 16 and 8. If I simplify 16 and 8, I get 2 upstairs. If I simplify x4 with x cubed, I get x upstairs. And then for these guys, I can just have the third root of the quotient, which is 48x cubed y squared divided by 3x squared y. Why can I do so? By the quotient rule for radicals, right? Just mentioned above in this section. Minus 20 over 4 is 5. And same game here. third root of 2x cubed y x to power negative 1. So certainly I can do so because this is the quotient of the cube root, and the quotient of the cube root is by the quotient rule for radicals. This is the cube root of the quotient. Okay. Now let's simplify this quotient for now. Well, 48 divided by 3, how much? 16, right? X cubed divide, okay, let me write this in parallel. So 16, so the 16 came from 48 divided by 3. X cubed divided by x squared is x. And y squared divided by y is y. Minus 5 times the cube root of 2 times x cubed divided by x to power negative 1. Remember, x to power negative 1 downstairs means x upstairs, right? Because the minus in the exponent means the reciprocal. So dividing by x to power negative 1 means multiplying by x. And 3 plus the 1 becomes a 4, right? So one more time. X cubed divided by x to power negative 1. Let me write it on the side for you. X cubed divided by x to power negative 1. Let's look at it differently than we talked about it. This is x cubed minus the minus 1, right? So you keep the base and you subtract the exponent of the denominator from the exponent in the numerator, right? Earlier property and probably a couple sections before. And minus the minus 1 becomes a plus 1. So 3 plus 1, which is 4, right? So this would be like a little explanation here. So here I get x to power 4 times the y. All right. And I can still simplify this guy because I have a divisor of x to power 4, which is a perfect third power, right? So let's do it. So I get 2x third root of, also I can do it for 16. Can see 16 as 8 times 2 and the xy minus 5 times the third root of 2x cubed times xy. Am I correct? Okay. All right, so that's 2x, the cube root of 8 times the cube root of 2xy minus 5 times the cube root of x cubed times the cube root of 2xy. Right, the language here, all of the languages here is multiplication, right? This is multiplication, multiplication, multiplication. So the only operation involved is multiplication. And the multiplication is commutative, so 2x cubed is the same thing as x cubed times 2. You can reverse the order and then use the product formula or the product rule for radicals. You can split them up as such, right? Okay, what's the cube root of 8? It's a 2. Now what's the cube root of x cubed? It's the x. So we get 2x times 2 is 4x. So 4x times this minus 5x times that. Okay, so as we did before, this is an image and this is the same image. It's the same image. So 4 of the image minus 5 of them is equal to minus 1 time that image, and the image is x, third root of 2xy. Okay. All right, so this is the end of this section.